L of the function f equals root 1 plus x at x equals 0. And then use it to approximate the following numbers. So here we need to find a linearization of this function. All that means this is a curve square root function. We want to approximate this curve by a line, straight line near at 0. Okay, so the equation of a straight line is y minus y1 equals mx minus x1, or this is same as y equals slope x minus x1 plus y1, and in this notation Lx, this will be our Lx will be slope at 0. So f prime at a, I mean we can call this 0 as a, or f prime 0. Okay, that's a. X minus this a, which is 0, plus y1 is the corresponding y value. So evaluate the function at a. A is 0. Okay, this is the formula, or we can just write a, generic number. A happens to be 0 in our case. Okay, this is simply just a. So let's find the derivative of this function. So the derivative is, this is square root of 1 plus x, means 1 plus x raised to 1/2. From the power rule, 1/2 1 plus x raised to 1/2 minus 1, negative 1/2 times derivative of inside function from the chain rule. Derivative of 1 plus x is simply 1. So this is negative exponent we can put on the bottom. So 1 over 2 and 1 plus x raised to 1/2. I'm just getting rid of this negative. So that's the slope at any point x, but we want at this a equals 0. So f prime at 0 is 1/2. 1 plus 0, 1. 1 raised to 1/2 is simply 1. 1 raised to any power is 1. So 1/2. 2 times 1 is 2. That's f prime 0. So that's the derivative. Now we need to evaluate the function at 0. So this one, if you look at the formula, this is now in our case 0. A generic a, but in our case 0. So f0, evaluate the function at 0. So f at 0 is square root of 1 plus 0, which is 1. That's simply 1. Square root of 1 is 1. Now then the linearization is f prime at 0, which is 1/2, times x minus 0, or just x, plus f0. The number is 1, which is 1/2 x plus 1. So basically what we did here is we can approximate this function. This is square root function by a line 1/2 x plus 1 near x equals 0. Whenever x is nearby 0, then this curve is approximated by this line 1/2 plus x plus 1. That's first part. Now in part A, we are asked to approximate the value of square root of 1.03. So 1.03 we need to write in terms of 1 plus x, so that we can determine the value of x and plug in here. So we want 1 plus 03 as 1 plus x. Okay, so we want 1 plus x is same as 1.03. Then we can find the value of x, and we plug that x into this linearization. Subtract 1 from both sides, so x is 0.03. Okay, that's the x value. Then this 1.03 is approximately equal to this linearization Lx, that x is 0.03. Okay, and that means that is, this is equal to 1/2 times 0.03, 0.03, same thing, plus 1, and using our calculator, 1/2 times 0.03 plus 1 will be 1.015. okay, 1.015. okay, and B, so we need to write 0.98 as 1 plus x. So 1 plus x is same as 0.98 when subtract 1 from both sides, so x is negative 0.02. okay, then 0.98 is approximately equal to this linearization at negative 0.02, and Lx is found to be 1/2 times x, so negative 0.02 plus 1. If we multiply and use calculator, this is 2 goes to 1 time, so negative 0.01 plus 1, so that is, if we subtract, this is 1 is positive, 0.99. okay, so square root of 0.98 is almost equal to 0.99, and square root of 1.03 is almost equal to 1.015 final.